stream, so I'm excited to go ahead and stream today. Hopefully you can see my screen. Awesome. Okay, so today we'll be working on reverse linked list. Classic. I feel like it's such a classic linked list fundamental problem that everyone ought to know. So, okay, let's go ahead and do this together. So this problem is called reverse linked list, and it's rated as easy on LeetCode, and it's part of LeetCode 75, and I love LeetCode 75, so definitely check it out. So given the head of a singly linked list, and it matters if it's a singly linked list or a doubly linked list, because doubly linked list, the difference between the two is that with a doubly linked list, you can go back and forth, easy, no problem. Versus as a singly linked list, you can only enter in one way, and then you can only enter one way through the head node, and you can't. Yeah, versus a doubly linked list, you can enter through the end node. So there's a slight difference between the two there. And you're gonna return the reverse list. Okay, let's go ahead and get started. So we receive a head of a linked list. We need to return the linked list in reverse. So if I have a linked list of, I don't know if they can have negative numbers, but if I have a linked list of 3, 2, 4, and then I want that to be returned, I anticipate to see a 4, a 2, and a 3. As you can see, the end node is now our starting node, and then the beginning node is now our end node. So what we can do here, edge case I think about to consider is that if there's no linked list to be passed in, we're just gonna return an empty array. An empty array. Gotta make sure. So we're gonna return an empty array. Otherwise, what we can do for this, so the number of nodes in the list is from range 0 to 5,000, and some of the node values can have negative values. I don't think it matters on sorted values. I think if the node come in that sequential order, we're just gonna return it like that. So what I'm gonna go ahead and do is I am going ahead and create a dummy node called previous. And what this dummy node will do, I'm going to create a dummy node called previous, and it is going, while I do that, I need to keep track of the current node. And then what this dummy node is going to do, it's going to help reverse the pointer. So in the linked list, a node has the property of the value and a pointer. I'm pretty sure here's what it's called, a pointer or a pointer. Pretty sure that's what it's called. I'm getting myself a little bit confused there. Keep track of the node. We're going to traverse through the linked list while it's not null, and we're gonna keep track of the next current node, and we're gonna take the pointer from the current node and point it back to previous node. And then after you do that, you have to iterate and now you have to move your pointers for previous, current, and next to the next nodes. So say for instance I have my list right here. I'm gonna say, hey, my previous, I'm gonna create, using my example above here, previous is a dummy node. So here I'm going to say dummy node, and this is going to point to 3, which is our current one. Using our example, this is current, and then while in the while loop, making sure, so in the while loop, so this is pointing to using my example above in line 16, oops, 2, this is my next. So you can see this pointer right here. This pointer is going to shift back and point to our dummy node. So it's going to point back to the previous node, hence why it's called return reverse, because you're going to point back to the previous, and in that way you're going to return the reverse linked list. So how I'm going to do that, so like I mentioned earlier, the edge case, if there's no head or the linked list is empty, we're going to return back an empty array. Otherwise, what we're going to do is new in the code, is it list node? I think it's called list node, because I'm thinking like it should be called LinkedIn or not LinkedIn, excuse me. It should be called linked node, but I think it's called list node. That's how you initialize a new node for a linked list. And then what we're gonna do is we're gonna keep track of the head. And then so what we're gonna do is we're gonna keep going while current does not equal null, because all linked lists at the end, when you know you traverse through it all, it will always point to null. So you know that when you get to when you hit null, then this while loop will stop running. And then like I mentioned, we're going to initialize a pointer to capture the next node. And we're going to say, hey, next node, the pointer, you're going to point to back to previous. And then, as I mentioned, this pointer here is going to point back to previous. Previous, let's move you up to where current is. And current, let's move you up to where next is. And then we're going to keep iterating through the entire linked list. Here's my 4, and then here is null. So in the second iteration, I anticipate to see previous move up, current and next move up, and then now it's going to keep pointing back. And then you can see here that eventually current's going to hit next, or sorry, current's going to hit null. And then now we return previous, and previous, as you can see, is our ending. And with the fact that we already switched pointers back, this should return us our reverse linked list. Oh, okay, it's not list node. I feel like I should know this. New list node, new node. Node. Is it node? New list node, okay. That's my fault for not reading the class there earlier. Okay, cool, list node. New line 63. There's no such thing as line 63. Runtime error, throw new error is not valid for it. Hi, Elder. Twitter message or so no worries. Take your time. So I'm working on. Is that what it is? Oh, you know what? It shouldn't be the previous. This one should be. That is my fault. Thank you for the catch there, Elder. So in my pseudocode, I am saying, hey, create a dummy node. And I am going to say, let the previous equal the dummy node. No, but you got me thinking, Elder. Okay, so now, yeah, because okay, so yeah, so I've initialized, yeah, you got me thinking there, because I think I got that mixed up there. So I'm going to initialize a node called dummy node, but I'm going to set that dummy node to equal previous. And what previous will do, as I mentioned earlier, previous will keep it. Previous is essentially like a pointer pointing to our dummy node. And we're going to keep track of that. And current, we're going to keep track of the head. which in my example, our head is going to start out with 3. And then so as I run back through this test, make sure I see everything. And make sure that you see everything too, of course. Okay, so our dummy node, our current, and so that's what I have initialized right now and what I'm keeping track of. And I am going to do, so I'm going to traverse through the linked list while the current does not hit null. Because if it does hit null, that means we reach the end of our linked list. And all the linked lists will always be pointing to null to signify that it is the end of the linked list and there's no more nodes that you have to traverse through. So that's always a property of a linked list. And then we're going to keep traversing through it. And in the while loop that we keep traversing, we need to keep track of the next node that we're looking at. And with that, we initialize a next variable to keep track of that. And then while we do that, we're going to say, hey, current.next, I want you to point back to the previous dummy that we're looking at. And here, we're going to always switch the pointer to look at the previous node. And then after that, after we switch the pointer, we will move everything up by 1 by saying, hey, you're going to equal what currently equals. And then current, you're going to equal what next is going to be equal to. Or sorry, yes. So essentially, yeah, we're going to increment them to the next value in the linked list. And by doing this, we're going to return the previous, because as you can see, as we keep traversing and we keep switching pointers back, previous is going to hit the end of the last node. So we know that current hits null, so our while loop stops, and we're just going to return whatever previous last was at. Oh, hurt me a little bit there. Alright, okay, so that didn't work. Line 64, throw new error is not valid value for expected return type list node. Return is not valid for the expected return. I think it's talking about my array here, because I anticipated that it should have been, an output should have been an empty array if this output is saying that it's an empty array. Are you anticipating that I should be saying null? Oh, that hurts even more. Okay, so it should have been null. But, okay, so we have an additional variable of a 0. We have an additional value of a 0. And I think that's created from our dummy node. Our output is 543210. Okay. So this is adding a value, and it shouldn't be adding a value. And then also for linked list, as I mentioned earlier, it will always be pointing to a null. And since we want it to be reversed, I anticipated 54321 and then null, because that identifies that it's the end of the linked list. So let dummy should be equal to a null instead of a linked list node. And then that is true here. So that gets us our solution here. Thinking about it, our time complexity is O of n. Our space is going to be return previous. Okay, so that's the reason why our time complexity is O of n, because we're traversing through each node in the linked list. So it will be O of n. Since it is a singly linked list, we have to go through all of the nodes until we hit null. So hence why it's O of n of how many nodes are in a linked list. Space will be O of 1 because we're traversing in place. traversing in place, because we're not creating, we're traversing in place and we're not creating like another linked list here. So yes, another way to do this too is also we could do it recursively. And to do it recursively, I have to go ahead, let me just boot everything down. Okay, perfect. So you can see it's recursive here a little bit. So right now the function is getting passed in the head of a linked list. And what we're gonna do is we're gonna pass in a default parameter set to null. And the reason what a default parameter is essentially saying like, hey, if the user doesn't pass anything, it's gonna be it's automatically going to be assigned to null. And with recursive, there's always a base case and a recursive case. And a base case is when you want to exit the function. You want it to stop calling. And when that happens is if the head, as I mentioned earlier, like the property of a linked list is when it reaches null. That means you traverse through the entire linked list. So if head, sorry, I was writing code there. If head reaches the end, if head is equal to null, then we can exit the loop and return the head, or return the previous, because we still want, the objective of this is still to keep pointing backwards. That's how you get the reverse linked list. In the recursive call, the recursive case where we want to keep calling this function is we still need to capture the next node. We still need to capture the next node. We still need to capture the next node, and then the next node, we're still going to make you capture the next node with a pointer. Sorry, my serial code is really quick and faster, so capture the next node, you're like, oh, I don't know what that means. Okay, but okay, we're going to capture the next node with a, or we're going to point to the next node. Have a pointer pointing to the next node. Better way to pseudocode. And then after that, we're going to say next, we're still going to say, hey, next node, we want you to point back to the previous node. And that will keep happening until it hits null, which is our base case, and then that will return the previous. So as I mentioned earlier, I still like to keep this other one, this other edge case here, that in case if the linked list is empty, if the linked list is empty, then we're automatically just going to return null right away. So this is another optional edge case to add to it, but the base case is that if head is equal to null, then we're going to return previous. And otherwise, we are going to say const next equals head.next, and then we're going to say return, no, sorry, head.next, you're going to point back to previous, and then return reverse list of, so the two new arguments that you're going to get passed in, because we want to make sure that, so what head is showing the current node that we're looking at, as I mentioned here earlier. Say for instance, right here, we still are keeping the fundamental, we're still keeping the base of dummy is still equals to null, which is previous right here. And then our head is actually our current. And then our .next is doing, our head.next is our next pointer right here. And then what we want to pass here in lieu of head and previous is saying head and previous is you want to pass in previous and next. Previous, head, previous, no, wait. Um, previous, next. I actually want to pass in. Okay, I'm thinking we're doing head and next. Head, next. Next, and then head. Because the reason why I'm gonna go with next is because, as you can see here, current is still in front of previous, and then next will always be in front of current. So we're going to say next, you're going to equal to the head. Oh, unknown identifier, unexpected identifier, reverse list. I think it's just the way this is written. Function reverse list. Oh, you know what? Spelling error. Return. Okay, so it's not next and head. Is it head and next? Yeah, that's what I was thinking. Oh no! I was gonna say it's previous. Yes! Yes, thank you everyone. I was like, what's going on here? Okay. So, I'm also stuck on line 23. I know that I need to pass in, I know I need to pass in two parameters. To call this in a recursive case, I want to call the function again until I hit null. And if I'm going to do that, what I currently have for head is the current. And what I have for a second argument there is previous. So if that's the case and I want to call this again, I want to make sure I call it on the two parameters. I want to call it on is previous and head, previous and next. Trying to think through my logic as to what two parameters I want to pass in. Return reverse list previous head. Does that make sense? Previous, yes. Okay, so for sure this is previous because I know that recursive and iterative are very similar to each other. And what I mean by similar is that I know that the functions almost. Can I minimize these? Nope. Okay, no, I can't. Oops, I didn't mean to put a breakpoint, but let me shrink the screen a little bit so you can see my ideology. Because I know that iterative and recursive do essentially almost the same thing. And I wanted to, as you can see down here, here is my iterative solution. And what I want the recursive solution to do is similar to my iterative solution, which I solved it down here. So as you can see, I already have const next is equal to head.next. So I'm moving the pointer called next to the next node, and then I'm saying that, hey, take the property of that pointer and point it back to the previous node, which is done here. And now I want to recall this again, which is similar to our step right here, where the previous is equal to current and current is equal to next. So if that's the case, I have head and I have previous, and if I want to do this again, I want to use head. I still want to use head, and I still want to use next. Head and next. Okay. Function head is equal. Any thoughts out there? throw a line out there. Previous is equal to null. I think your head. Return reverse list of next. Let me go through an example. It still doesn't like it. Okay, so let's figure this out. I'm gonna go through my example. Okay, so I have head in a previous node set to null, and that's essentially what, let me just replace dummy, we'll call it null. Okay, so previous null is right here. My current, let's rename this to head for this example. So my head, if it's empty, then we're just going to return null right away. Otherwise, we're gonna go ahead and keep iterating our base case to exit the function. Is that if head is equal to null, meaning that it's hit the end of the linked list, we're gonna check the output of your item. Output of my item. When you see the output of your item, Elder, do you mean console.log console.log next and head? Is that what you're saying? Console.log head.next. Okay, so let's see. Okay, let me know if I grabbed the correct variables, unless you were thinking something else. Should I be pulling in previous variable as well? Let me know. So, okay, so I have this example here of this linked list of 1, 2. Right now, our next is currently a 2, which it should be. And then our head.next hits null. Console.log. Okay, so the first round const next equals head.next. Yep. Okay, and then so did I previous, are you at previous is null? Yep. Previous is null. So given this case example down below, let me comment it out just in case Elite Code wants to run it. I have anticipated, okay, so using this example, case 2 here, previous, using this example, and with what I have created as a default parameter, this one should be null first, which is true because my previous pointer is equal to a null, which I want, and then 1, 2, and then a null. And then this should have been head, and then this should have been next. Let me just move it out just to make it look cleaner. Okay, so if head is equal to null, return the previous. Otherwise, next is equal to head dot. This is head dot next. And head dot next, hey, I want you to reverse pointers and point back to the previous. Const head dot next. Head dot next, I want you to point back to the previous. But as I can see here, null to null, head. If head equals null, return previous. I think it's because I'm saying that if head is equal to null, so this is previous, this is next, const next equals head dot next. They wouldn't. I don't think I'm keeping track of head. I think I did. I think what I did. Okay. Ah, something was working there. Something. Then I think it's still okay. At first, I was thinking it's if head dot next is equal to null, but head dot but it's not head dot next because if I think about it, I want to keep iterating, and I still want head to hit null. So my base case is still correct. It's just my recursive call because head should still equal to null, and that's when I know I need to exit. And I've seen it all because I was almost thinking it should have been head if head dot next equals null, but we don't want that. So my base case is okay. So it's my recursive call. Const next is equal to head dot next. Okay, so I capture that into a variable called dot next. I capture the next into a next variable. And then head dot next, I want you to point back to the previous. I want to see what previous is doing. Let's take it step by step and break down into the variables previous, and then okay, previous is currently pointing to null, and then it's currently pointing to 1, which is correct. I anticipate previous to move from null to 1, so previous is moving in the right direction that I want it to. But it's not linking. Is it because I need to? And then what is head doing? Head, are you moving the right way that I anticipate you to move? 1 and then 2, 1, which is correct. I'm almost there. I feel like I'm almost there. Okay, so previous, I know that our previous variable is good. It's moving in the right direction that's going to. Head looks like it's also moving the right direction that it needs to as well. Head dot next. Sorry, I keep looking at the iterative. I feel like I know, I feel like the answer is right there. I think I need to return. I feel like, sorry, let's check head dot next as well. Null and 1. Next, yep, I think it should be this is because head down next is pointing backwards, And I am anticipating that it should be pointing back to 1. Any other hints y'all can throw out before I search it up? I feel like, oh, I was so close. The recursive call. Any other tips or hints out there? Previous. Oh, it still doesn't like it. Previous equals current. Previous is equal to null. Oh, it should have been. I really next, and this should have been head, because in lieu of previous base, head will always keep incrementing to that. Hi Rich, hi Richard, hello. We're trying to figure out how to do a recursive call in linked list if you're familiar with that. So, Elder, any tips and tricks as to what I did wrong? I feel like I'm so close. Like, I think. Yeah, Richard, I was planning to, but yeah. Next time for sure. Next time. But yeah. So I am trying to figure out this recursive call right here. If you guys have any idea as to what I'm doing incorrectly. Yeah, I know I definitely should, Richard. So, yeah, if you guys have any tips and tricks as to, or see anything wrong, because like in my recursive call, sorry, let me throw it back a little bigger. But if I make it a little bit bigger, I definitely, you're close indeed. I would recommend you console log before the edge cases. You're close indeed. I would recommend you console log before the edge cases and label things. Okay, with that stated, let's go ahead. I forgot what yeah. Okay, so console.log head, and then I want to go ahead console.log previous, previous oops, sorry, that's my fault there. Console.log, I want to say head. You're close. I'm going to recommend you console log before the edge cases and label things. Head previous. I don't think head.next exists yet, but yeah. It's not in a global scope. Okay, 1, 2 is our head. And then previous is null, which is correct. And then head becomes 2, previous becomes 1. We can return previous. Okay, so so it's doing what I anticipated to, Elder. You can have multiple console logs. Oh, thank you. Yeah, I next time, Elder. Yeah, but it's doing what I anticipated to do, where head is equal to 2 1 2, and then null is equal to previous, and then it's pointing backwards, and then now head is hits null, and our previous has 2 1, and it should return the previous. Oh, well, sorry about that. I wanted to cut it short a little bit. Yeah, I had to get hopping on this and fix up some files, but let's do this again soon. So we'll definitely do some more.